Okay, guys, so now that we've done some practice with empirical formulas, it's time to start the molecular formula. And luckily for you, the molecular formula is not that different. So as long as you master the empirical formula, molecular formula should be a breeze. So the way that molecular formula works is that as we discussed before, the molecular formula is what's naturally found in nature of an empirical formula. The subscripts are what's naturally found in nature, whereas empirical formula is the simplest numbers of subscripts. So the way that you find molecular formula is the molecular formula mass, which should always be given to you, divided by the empirical formula mass, and that is equal to a number. That number, it could be 2, 3, 5, 8, I don't know. That number, you apply that number to your empirical formula and multiply that number to the subscripts of the empirical formula to find the molecular formula. And let's go over some steps. So first is to find the empirical formula, and then find the empirical formula mass, or just its molar mass of the empirical formula. Then divide given molecular formula by the empirical formula, just like how here, and then multiply each subscript by that number, just like how I just said there. I think the best way you'll get it is to do some practice. So let's go and practice. Question 1. What is the molecular formula of C2H4O if its molecular mass is 176 grams per 1 mole? Okay, our first step is to find the empirical formula, and that was already given. Great. We just saved a step. Next, let's find the empirical formula mass, or this molar mass. So the molar mass of C2H4O is just some simple multiplication. Simple multiplication meaning that carbon is 12 times 2 plus 1 times 4 is 4, and the oxygen is 16, which means that 24 plus 4 plus 16 is equal to 44 grams per 1 mole. This is the empirical formula mass. Okay, now step 3. Divide given molecular formula mass by the empirical formula. So I'm going to do 176 grams divided by 44 grams, and that is equal to 4. And this is this N value that I had just shown you earlier. Now I'm going to take my empirical formula, which was C6H4O, and apply this subscript. And now I just have to simplify it. So apply that number to there, meaning that my final answer now we've gotten 4. Now step 4 is to multiply each subscript by that given value, which was that N, which we found was the value of N was 4. Meaning that I'm going to do 176 divided by, meaning I'm going to get the original empirical formula, which was C2H4O, and I'm going to multiply the whole thing by that subscript of 4. And I'm going to apply the 4 to all of the subscript, meaning that my final answer should be C, 8, because 2 times 4 is 8, H, 4 times 4 is 16, O, 1 times 4 is 4. Meaning that your final molecular formula is C8H16O4. This is basically what that means, is that this is what's naturally found in nature, whereas this is the simplest subscripts. Okay, now it's time to do question number 2. So question number 2 says, a compound is found to be 75.0% carbon, 8.34% hydrogen, and 16.66% oxygen. Its molar mass is 180 grams per 1 mole. Find the empirical formula and the molecular formula. Okay, so our first step is to find the empirical formula. First things first, I want to, because it's not given the mass of like the whole compound, we're gonna assume that's 100 grams, okay? And this is again the most simplest and efficient way, because then I know that if it's 75.0% carbon, then it's just going to be 75.0 grams. And then the same math goes for everything else. 8.34% hydrogen is just 8.34 grams. And then the same thing for oxygen, 16.66% of oxygen is just going to be 16.66 grams. Now I found the mass. Now we are going to find the number of moles, right? So divide by the atomic mass unit. Atomic mass unit of carbon is 12, so divide this by 12. and then your number should be 6.25 moles. Divide this one by 1 because the atomic mass unit of hydrogen is 1. And you should get 8.34 moles. And then divide oxygen by 16. And then you should get 1.04. Divide 16 by 1. And divide oxygen by 16, which you get 1.04 moles. Now, out of these three, what is the smallest number? Out of this, this, and this, it's 1.04, meaning that I'm going to divide each of one of these numbers by 1.04 to find my subscripts. And then these values should come out to, these are just like really long numbers, but it's 6.251, and then this one is just 8.34, and this one is just 1. And these numbers are pretty much like close to the whole numbers, meaning that you can just say that this subscript is 6, this subscript is 8, this subscript is 1, meaning that the empirical formula is C6H8O. That's your empirical formula. Now, I have my empirical formula. Now I'm going to find my molecular formula. How do you do that? Well, first things first, I'm going to find the mass of this empirical formula. To do that, carbon is 12 times 6 because there's 6 carbons, plus 8 plus 16, and you should get 96 grams per 1 mole. The molar mass, which was 180 divided by 96, and it's like 1.875, or you can just say 2, it's like around 2. This number is what was said as N. Now I found N, I can apply the number of N to the empirical formula. So if it's C6H8O times 2, I'm going to apply the 2 to all of these subscripts. So my final answer should be C12H16O2. That is your molecular formula. That's it for today. Thank you guys so much for watching, and I'll catch you in the next one.